It just looked like an old Saab to you all, and in fact it is, apart from one aspect, and that aspect is what you see that's red here. That's the cylinder head, which has been modified to accommodate My name is Christian von Koenigsegg. I'm 40 years old, and for half of my life I've been on the quest to be a leader in the hypercar industry, utilizing Swedish design combined with visionary technical solutions. Our latest car, the Agera R, is built in the old hangars of a former Swedish fighter jet squadron. Their symbol, a ghost, is now proudly painted on the back of every Koenigsegg. So now I'm going to show you something which we're working on for the future, which I personally find very, very interesting in many aspects. So what this is what we call an actuator. It's a Freevalve actuator. Most of you who are familiar with combustion engines and especially car engines know that there are camshafts involved to move the valves inside the cylinder head. And these valves, they have been controlled by camshaft for the last 150 years or something like that. But it's very restrictive really, especially if you have multi-cylinders and you want to have a rev range to go through with efficiency and power. Because when you have a camshaft, you basically lock up all the cylinders in the same line to do pretty much the same thing. There are coming systems now which give some flexibility. You can tweak the angle a little bit compared to the crank of the engine, and you can slide them sideways like Audi is doing to shut off cylinders now. So it's getting better and better, but it's still very, very restrictive. You can think of the camshaft like a broom. Pretty much you hold it in your hands and you push all the valves simultaneously with this broomstick. What the Freevalve system does is that each valve becomes individual. So if you think of the valves like keys on a piano, suddenly instead of pushing all the keys at the same time with a broomstick, you can actually play the keys with your fingers, which is the free valve idea. And then of course the engine can perform in a completely different way than being forced into a preset pattern of combustion. So what we're going to show you here is this is like a small cutout of a cylinder head. Here we have one valve. Normally there are two intake valves and two exhaust valves, but here is just a small rig to run one of these Freevalve actuators. So basically here you have the valve, here you have the actuator. It goes into like this. This is lubricated by engine oil and pressurized by pressurized air, which acts like an air hammer to move this out. Then the engine oil makes sure it stays stable and can lock it in different positions, and then air or a metal spring, air spring or a metal spring pushes it back. So we have individual control over each valve, which brings great benefit to the combustion cycles in the engine. So it's actually a snowballing effect. The engine becomes lighter, smaller, cheaper, cleaner. It can change the look of the car in the end. So it's a very, very interesting technology that I'm sure one way or the other will conquer the cylinder heads of the world. So here we will go in a little bit to details how it works. Urban, who's partly responsible for this development, will show you a little bit what it looks like.
It's a very simple control system. We have one signal for each valve, and when we tell it to open, it opens with a few milliseconds delay, and when we tell it to close, it closes with, again, a few milliseconds delay. This it can do at very high speeds, up to 20,000 RPM if necessary.
The same size of actuator is actually good for a small motorcycle engine revving 15,000 RPM and a truck engine revving 2,500 RPM. Because the motorcycle valve is very light, so it takes the same energy to drive it backwards and forwards at 15,000 RPM as it takes to drive a huge heavy truck valve backwards and forwards at 2,500 RPM. So it's very neat that the same actuator basically covers the need for all different engine sizes. So now we're running at what kind of RPM here?
Well, here's a little bit over idle.
this is actually the movement of the valve. So you can see it goes quickly up and then it stays flat up. It's like having a square camshaft profile to make the engine breathe really well. If you would have a square camshaft profile, it would break immediately because it would jump off the edges and would start hitting the valve stem and it wouldn't work. But with the Freevalve system, you can actually open any way you like and open really fast, stay open flat and then drop down. Here it's possible to see the valve seating as well, that it's a smooth curve so it doesn't hit the valves, it creates noise and wear.
This is 3000 RPM, and you can see still a square form of the valve curve. It's 9000 RPM.
So this might just look like an old Saab to you all, and in fact it is, apart from one aspect, and that aspect is what you see that's red here, that's the cylinder head, which has been modified to accommodate our Cargin Freevalve system. So basically what we've done here is we've taken the cylinder head apart, machined out all the mountings and so on for the camshafts, and installed 16 Cargin Freevalve actuators. And then we have designed a special valve cover, or it's not really a valve cover, it's more a lid containing pressurized air channels and pressurized oil channels coming from the engine oil side. You can see the height of this black cover here. That's the same height as the standard cylinder head used to be. So even when we retrofit it, when it's not optimized for space, it's anyway lower than the standard cylinder head, so the engine actually shrinks and becomes lighter. If we would have made a cylinder head from scratch instead of retrofitting into an existing cylinder head, it would also become much narrower and even lower. And this whole section here, which is a cover for where the chain drive for the camshaft used to sit, would disappear completely, so the engine would also become a lot shorter. Basically, when you go from a camshaft to Cargin Freevalves, the size of a 4-cylinder engine becomes just a little bit bigger than the size of a 3-cylinder engine. And then of course if you cut away one cylinder to maintain the power and torque level you used to have in your 4-cylinder engine, then it becomes really much smaller. So this car here has been running with Cargin Freevalve system winter and summer for the last 2.5 years. We've accumulated almost 60,000 kilometers without any failure whatsoever to the Freevalve system. It's just been upgraded with our latest generation actuator, generation 5, on both the intake and exhaust side of the engine. And it's been up-tested at a testing institute called AVL with up to 20% improvement in fuel efficiency so far. This is, and that's just the starting point, I would say. This is more a test mule to run for durability and for cold starts, even in the winter down to minus 20 degrees Celsius. But it's really exciting, and it's I think one of the few cars in the world that is running with no camshafts whatsoever. When it's fully optimized, we're expecting to have 30% less fuel consumption, 30% more torque and 30% more power, and in an average driving cycle, 50% less emissions. And that's without connecting it to the possibility, which is very interesting, which is an air tank. Given this valve technology, we can actually recoup energy while engine braking by using the engine as an air pump, pumping up a tank with air, getting air pressure there, and then driving off only on that air, using the engine as a compressor or let's say an air engine. That compressed air can also be used for boosting the engine while using fuel to have like a really big quick spooling turbo which consumes no energy. So instead of storing energy in a battery, an electric battery, we're using an empty tank of air. So that's kind of the next step of this technology, but already without that it's huge benefit compared to normal camshafts. This technology is not yet in Koenigsegg, and it's something of course we might plan to do for the future. Will be another 3-4 years out. before it's in any production car, and hopefully the Koenigsegg could be one of the first. My name is Christian von Koenigsegg. For half of my life, I've been on the quest to be a leader in the hypercar industry, utilizing Swedish design combined with visionary technical solutions. Koenigsegg is a company known for developing extreme technology for hyper and mega cars and so on. But a lot of the stuff we're doing, and especially our sister company Freevalve, is now trickling down into also more normal cars. And with the Freevalve technology, for example, here's a typical example where supercar technology can also work well in a normal car. For example, we're using our Koenigsegg engine management system to run these engines. And we have this kind of throwing backwards and forwards of ideas that works just as well in a normal car as in a hyper mega car. What we're looking at here is a customer project we're doing where we are taking an existing 1.6 liter turbo engine producing 160 horsepower and 240 newton meters of torque. It has port injection, not direct injection. It's for a Chinese car brand called Coros. It's a quite modern engine they have. It's developed in Germany and Austria 5-6 years ago, so it's not something out of date or anything. But it's at the same time a good base to revamp for the next generation of technology. So what we did, we got the CAD drawings for that engine and changed what we needed to change to make it into a Freevalve engine. And what we're looking at here is the main part of that revamping, and that's the cylinder head. So this is the original Coros cylinder head, which is very contemporary looking and equivalent to most modern 1.6 liter four-cylinder engines. We just stacked this up on a box here, which is pretty much the same height as these rubber cushions which this head is standing on, just to show you the height difference of the cylinder head. Lowering the engine is very important to car manufacturers, and here we managed to lower, not only increase the functionality of the cylinder head, but also lower the cylinder head with about 50 millimeters. And it's also 70 millimeters shorter and narrower. So all in all, the engine shrinks due to the fact that the cylinder head is so much smaller. Then we don't need the camshaft drive here either. Here, this is just, we don't need that. I mean, we have pneumatically operated actuators in here, so that also shortens the whole front side of the engine and the FIA, the drive, belt drive in the front of the engine. All in all, the engine is about 15 to 20 kilos lighter depending on specification, which is very big difference. So there's a lot of raw material savings there. But most important, of course, is the fact that we get free control over the valves, so we can operate each valve individually, and that really improves the combustion process drastically. So with the Freevalve technology, each valve can be held at a certain position, decided not to be lifted, or fully open and held there as well, individually from each other, timing-wise, individually, completely. So we take benefit from that. So you can see on the intake side, and it's the same on the exhaust side, there is one port for each valve. And you can also see the port shapes are a little bit different, because when we run in one intake valve mode, we get different tumble and swirl effects, so we need to adapt to that a little bit. And we can also operate the exhaust valves individually, and we can shut down cylinders, of course. As you can see on the dyno test we're doing with this engine, we have separated the exhaust ports, so every other exhaust port goes straight out into the exhaust and every other one goes to the turbo. That means we don't need a wastegate because we can control the turbo pressure with the opening of the turbo valves and how much we bypass straight out into the exhaust. And as we bypass every other valve straight out into the exhaust, the total back pressure can be lower on average, and we can heat up the exhaust system and the catalytic converter much better in cold start than any other turbo engine, partially because we're bypassing the turbo and partially because we can combust in a completely different way to shoot out long flames in the exhaust during cold start. So that way we have no need for the pre-catalytic converter anymore. The pre-catalytic converter is only there for the cold start really to get hot quickly. We can heat up the main cat as quickly, so we can save a lot of money by removing the pre-catalytic converter. Also, as we have free control over the valves, we can throttle inside the combustion chamber. So many of you know how a race engine have a small plenum volume with a throttle to have good response, or even a throttle on each intake tract to have very little volume behind and to have good response. We're actually throttling inside the combustion chamber, so there is no way to get better response than that. On top of that, we have less losses in the intake because we don't have to pull under pressure in the intake between the throttle and the engine. We can have atmospheric pressure there or overpressure with turbo. So that alone saves around 4 to 5% of fuel consumption. And again, it saves weight and cost because we don't need a throttle body. The final kicker, I would say, is that we don't need direct injection. We're running a turbo engine here with 12:1 in compression ratio, or maybe even up to 14:1 in compression ratio. This one is down to 9:1 in compression ratio, which is normal for a turbo 4, I would say. So higher cylinder pressure than any directly injected turbo engine with port injection. And the benefit of port injection compared to direct injection is that it's much cheaper because you're running at lower pressure. It's higher volume production still, so it's cheaper due to that. And you avoid getting particulates into the exhaust because you get cleaner combustion with a more controlled combustion of the fuel entering in the cylinder. The advantage of direct injection is that you can cool the cylinder, and that's good for a turbo engine. But we can cool the cylinder in other ways by flushing it and spooling it between the cycles. So there isn't really any benefit for us to put direct injection, but there's a huge cost saving and we don't have the particulates problem. So in the end, what does this do for the engine in this case? So in our dyno testings and our simulations, we're seeing a huge increase. I mean, we still have a small production turbo here, but we're seeing a huge increase in torque, 47% torque increase. From 240 Newton meters to 320 Newton meters of torque. 45% power increase from 160 horsepower to 240 horsepower. Fuel consumption saving of around 15%. Emission reduction of around 35%, mostly due to a much better cold start. Usually any combustion petrol engine, as soon as it's warm, is very, very clean. As soon as the catalytic converters are warm and the combustion chamber is warm, it's very little pollution. But during the cold start, you have a lot of pollution. And this system really improves the cold start drastically. So yeah, huge saving in every aspect.
Hello everyone and welcome. In this video we're going to be talking about Koenigsegg's Freevalve system, and these are actually two different companies. They're sister companies, Koenigsegg and Freevalve, but we're going to be talking about their camless cylinder head design here, which uses an actuator rather than camshafts to open up the intake valves as well as the exhaust valves. And so this is a simplified version. I have a separate video that goes into, how do actuators work. This is an electro-hydraulic pneumatic, so using all the energy out there in order to, have the perfect valve opening and closing system. The process here is, though, pretty accurate about what they do. So basically what happens, and again, oversimplified version, it's going to be more complex than this. I'm not sure exactly what they're doing, but this is a good representation of how the system works. The more exciting part is definitely the advantages of this system. So you have this actuator right here and then a valve. Those are really your two parts. So what happens is you have an electronic signal. That electronic signal tells air to come in. So you have a valve here which allows air pressure to come in and pushes this piston down here, which is forcing this valve down, opening it up, allowing for airflow. Then you're going to have this oil pressure, which is going to lock this piston in place. So how this mechanism works could be many, many different ways. This is just a very simple pin that stops it and prevents it from going further. So it chooses that lift height. You could have different ways of doing this so that you could set it at any lift height. But basically the oil is there to stabilize it, lock it in place, make sure that that valve isn't kind of bouncing around as a result of having a spring on both sides. Then you're going to, once you've opened it up, you've let your airflow happen, you're going to release the air and oil pressure, and then you either have an air spring here or a mechanical spring or a combination of both, and that spring forces that valve back up, closing it, and you've gone through your valve actuation. So instead of using a camshaft, you're using air pressure really to open and close it, oil to lock it, stabilize it in place. So what are the advantages? This is the exciting part of this kind of system. And basically the biggest advantage here is that you have independent control of lift, timing, and duration of all of your valves for all RPM. So any individual valve you can control however you want. So looking here at a traditional camshaft, if you had a single cam profile, it'll open up, it'll go to its peak lift, and then it'll close back down. Open up, peak lift, and then close back down. With a system like this, however, you can instantly just go open, all the way open, leave it there because you don't have that cam profile that you're, required to use. So you can only have one peak point. So you can leave it there and then close it completely. And so that gives you a lot better airflow. Now that's, let's say you want to do that for high RPM. Well, for low RPM, you might want faster speed so you get a better air-fuel mixture. So you can use a smaller lift profile for a shorter duration at low RPM. So you have all these different options which you can choose rather than just that single cam profile, which is the traditional method of opening and closing valves. So that's the biggest advantage. It gives you a ton of control over each individual valve. Now, packaging and weight is also a benefit. You don't have that big bulky cylinder head with dual overhead cams or whatever it may be. You don't have to have a timing belt, so you can shorten the length of the engine or a timing chain. You can easily run the Atkinson cycle, and I have videos linked in the video description for a lot of these things if you're not familiar with how they work. Cylinder deactivation is very easy using these. You can control the valves individually, shut off any 2, 4, 6 cylinders, however many cylinders you have. You can play around with it a lot more. It makes it a lot easier to do than with traditional mechanical methods. You can eliminate the throttle body. So this is what BMW does with their Valvetronic system. You can do that exact same method with these, and that makes it significantly more efficient. That's why BMW does it, about a 10% efficiency gain just from having the throttle body wide open and having that pressure right at the valves rather than a vacuum between the throttle body and your valves. And then fully optimized, Koenigsegg says that this will give you 30% less fuel consumption, 30% more torque, 30% more power, and 50% less emissions. So, combining all of these benefits, that's kind of what it's going to come down to. So a ton of benefits of this system. So why isn't it seen in every vehicle out there? Well, two main reasons. Probably cost, because it hasn't been mass manufactured, so the cost is going to be high for those initial early adopters, and they may have some testing that still needs to be done, some kinks that need to be worked out of the system. So I'm betting on cost being the big driver there of why this isn't widely implemented. But the company Koros, Chinese company, did unveil a concept at the Beijing Auto Show in 2016 using this Freevalve system. So hopefully, as a result of this concept, we may start to see this come into mass production. So thank you guys for watching, and if you have any questions or comments, feel free to leave those below. This is my cat, Bucket. You got anything to say for yourself, Bucket? Just biting your tail.